On a moonless night in southern Africa, the ground is almost completely dark, and above it, the Milky Way stretches from one horizon to the other. Somewhere down in that darkness, something is moving with a purpose that seems entirely out of proportion to its size. It is an insect roughly the size of a thumbnail, and it is walking backwards, upside down, pushing a ball of dung with its hind legs. It cannot see where it is going. It has no landmarks to work with, and yet it is holding a line so straight it looks almost deliberate. For years, nobody could say with any confidence what it was steering by. In 2013, a team of researchers finally found out, and the answer was the galaxy overhead. The study appeared in the journal Curren Biology on the 24th of January, led by Marie Dacquet of Lund University in Sweden. Before that paper, only 3 groups of animals were known to orient themselves by the stars: birds, seals, and human beings. Nobody had ever expected an insect to join that list, and certainly not one that spends its entire life pushing dung across a few square meters of soil. The species is called Scarabaeus satyrus, and to understand why it needs a compass at all, you have to understand what happens at a fresh pile of dung. It is not a peaceful gathering. Dozens of beetles arrive within minutes, and the competition for that resource is relentless and often violent. A beetle that manages to shape a ball has only moments before another one tries to take it, and theft is constant. So the escape matters more than the destination, and this is where the logic becomes genuinely elegant. The beetle does not need to know where it is going. It has no destination in mind and no map of the terrain ahead. It only needs to never turn back. Any direction at all will do, provided the beetle can hold it without drifting into a curve. Because a beetle that curves even slightly will eventually arc back into the fight it just escaped and lose everything it worked for. Researchers already knew these beetles could steer by the sun, by the moon, and by the patterns of polarized light those bodies create across the sky. But an oddity kept appearing in the field notes. On clear nights with no moon at all, many beetles were still rolling in near-perfect straight lines. And when clouds rolled in and covered the sky completely, that ability collapsed. The beetles wandered, circled, and lost their way entirely. Whatever the beetles were using, it was clearly somewhere above them, and it was not the moon. To test that idea, the team did something that sounds absurd until you consider how carefully it isolates the question. They made tiny cardboard caps and fitted them to the beetles so that the sky above was blocked while the ground below stayed perfectly visible. The capped beetles lost the line immediately. They spiraled, doubled back, and could no longer hold a straight course at all. That confirmed the sky was the answer, but it did not say which part of the sky, and testing that properly meant being able to switch the stars off. So the researchers borrowed a planetarium at the University of the Witwatersrand in Johannesburg and brought the beetles indoors. Under a full projected starfield, the beetles rolled straight, exactly as they had beneath the real sky outside. Then everything was switched off except the Milky Way itself. A single pale band of light across the dome, and the beetles rolled just as straight. Finally, they were shown only a scattering of bright individual stars, and under those conditions their performance fell apart completely. The conclusion was that the beetles are not reading individual stars at all. They are following the bright stripe of the galaxy as a single line of light. The method itself was quietly clever. Rolling speed stayed roughly constant, no matter what the beetles could see, even in complete darkness. That meant the time taken to reach the arena's edge was a direct measure of how straight the path had been, with no need to trace the route itself. A beetle reaching that edge dropped through a gap into a trough below with an audible thump, and that small sound was the researcher's stopwatch. There's a human detail in this story that is easy to miss. Beca had attempted a version of this experiment years earlier, and it had simply failed. Only now did she understand why. She had run it in October, when the Milky Way sits too low in the South African sky for a beetle to make any use of it. The work went on to win an Ig Nobel Priz, an award given to research that makes people laugh and then makes them think. One honest caveat deserves stating, because it is the part most retellings quietly leave out. The beetle is not navigating the way a sailor does. It is not reading the galaxy, and it has no sense of where the galaxy is or what it means. It is locking onto a bright line above it and holding its angle against that line, which is a far simpler thing and somehow a more astonishing one. An animal with a brain smaller than a grain of rice that will never leave a few square meters of soil is using the light of 100 billion stars to solve a problem about a ball of dung. What else do you think is quietly using the sky while we sleep? Share your thoughts below and subscribe for more journeys like this one.